Hello, my name is Mohammad Hossein Rimaz. I am Master of Computer Science student at Technical University of Kaiserslautern in Germany. It is a pleasure for me to present this paper in this workshop on behalf of my colleagues. The title of the paper is AudioLens Audio over Video Recommendation for Mitigating New Item Problem. First of all, I will talk about the idea of this paper, an introduction. Then I will talk about the dataset that we have collected and the exploration. Then I will discuss about the recommendation result based on the data that we have provided. And then we will talk about the future works. And at the end, we have Q&A. So movie recommenders are one of the oldest use case example for recommender system. We have many industries that work on this topic, such as Netflix and Amazon, and we have lots of researches on this topic. We have very high quality and a standard dataset, such as the AudioLens dataset. So in movie recommenders, we are usually using genre as a very important source of information. We might use information about the actor or actresses of the movie or directors and such metadata to improve the quality of our movie recommender system. In some cases, we might use the user provided tags or reviews as a source of information to enhance the quality of our recommender system. And in some cases, we might use the popularity and critics review to solve some issues in our recommender system. So even though that we have explored this area, recently we are seeing newer exploration in this domain. For example, my colleagues have previously worked on using visual features as a source of information. These visual features could be high level, such as the general feeling of a main character. For example, the main character is angry or sad. We can use the mid-level features such as there is some object inside the room, there is blood inside the scene, and we can use low-level features such as using the dominant color information or the motion inside the scene or such features. But we have done very limited work on using audio features. So why we are missing this source of information? So for the visual features, we have many datasets available. We have the mise-en-scene as one of the first dataset, and we have some following other datasets for visual features. So what is the intuition behind using visual or audio features for the task of movie recommendation? So the problem is that when we have a new item in our catalog, we don't have any user provided data for that item. This is a problem called new item called the start problem. In such cases, when we have no tags or no ratings for that item, we cannot do the recommendation accurately. In some cases, we don't have any expert provided metadata such as genre, topic, category, or such features. So we need an automatic feature extraction method, and we can use this visual information or audio features information to just provide some features for these items and do the task of recommendation more accurately. So watching movie is not a complete visual thing. So in this blog post from Shutterstock, you can see same video, but they put different soundtrack on that video. And the question is that how this music can guide the viewer perception or create different feelings. Soundtrack plays an important role in the movie industry. So, for example, in Dunkirk, the movie directed by Christopher Nolan, The soundtrack composer Hans Zimmer is using a specific technique called Shepard tone, which is a kind of music composition technique that contains a continuing ascension of a specific tone. So with this technique, they are creating a never-ending and continual feeling of intensity. So in an interview with Business Insider, Christopher Nolan explains how they are using this technique to intensify feeling and create tension in the movie. And as another example, we have many great movies, but their soundtrack is more popular than the movies, and we recognize these movies from their theme. For example, Harry Potter or Star Wars movies. In order to explore how these visual or audio features could be used in this recommendation domain, we need, of course, dataset for it. So for visual features, we have some available dataset, but for audio features, we only have very limited dataset that they have some problems. So the first dataset contains very low number of movies, only around 800. The second dataset that we know is MMTF 14K. The number of movies, users, and rating is fine, but the problem is that they are using very low-level audio features, I vector and block vector features. And they are also using only the movie trailers or short clips of the movie, not the full-length movie. In another dataset called Music Supervisor, they extracted audio features from 41,000 movie, but their approach is completely automatic without any manual check. And the other problem is that the dataset contains very few common movies with AudioLens dataset, only around 3,000 movie. So we need to collect a high quality dataset for our task. So we choose to use Spotify because it has a great library and it also provides an API for extracting musical features. So we use a Spotify search API at first step to acquire the Spotify identifier for each movie. So we queried the name of the movie with a specific pattern. For example, you can see how we did it for Dunkirk, but there are some shortcomings. The problem is that not every movie's soundtrack album follow this naming pattern, and although some movies do not have any related published album in this platform. So our solution was to use an extensive manual checks by an expert to just find these edge cases and fill the missing rows in our data set. So in order to do the manual checking, we use some criteria. We use the Wikipedia or IMDb, and we compared the artist or the track names. We also compared visually the album poster and the movie poster, so they might share some common elements, some common fonts, or things like that that make us sure that this matching is correct. And at the end, if we are inconclusive about our decision, we will remove this item from our dataset. So at the end, for each movie, we have a corresponding Spotify ID, which could be an album or a playlist. So then we can use the Spotify audio feature API. So before moving forward, I have to address one specific question. So at the beginning, we mentioned about the cold start problem. So how a semi-automatic approach can solve the cold start problem? Because in our approach, we have manual checks. Well, first of all, we can develop some heuristics for doing this matching automatically. So this is possible, but this doesn't guarantee 100% accuracy for the acquired data. With manual checking, our intention is to create a good baseline dataset for further researches. So, in theory, we can develop techniques for extracting such features from full-length movie, though this is a computationally expensive task, but it is possible, and if you are an expert in the field of audio signal processing and music understanding, it could be a good data set to use as a baseline in further researches. But this is out of the scope of our research question. Spotify Audio Feature API provides these following features for each track in album or playlist. The first one determines how acoustic track is. The value is between 0 and 1, which is a confidence measure. The next one describe how suitable a track is for dancing. Energy is a perceptual measure of intensity and activity in the song. So, for example, black metal songs have higher energy. Instrumentalness is the likelihood that the track contains vocal content. So if the value is 1, it means that there is no vocal content in the song. Liveness measures the presence of an audience in the recording. Speechiness detects the presence of a spoken word in track. Valence measures the musical positiveness. So positive track, happy, cheerful songs have higher value, and sad music have lower value. We also have loudness, which is the overall loudness of the track in decibel. We have the popularity of the track in a Spotify, which is a value between 0 to 100. We have tempo of the song, which is the speed or pace of the song in beats per minute. We have the track duration in millisecond. We have also the key, the estimated overall key of the track, which is in a standard pitch class notation. So for example, 0 means the track is in C, 1 means it is in C sharp or D flat, and if it is -1, it means that no overall key is detected. The mode of the song determines whether it is major or minor, or -1 if nothing has been detected. And we have time signature which specify how many beats are in each bar. We are using the AudioLens 25 million dataset released in 2019. It is the latest version of the dataset. In our dataset, we cover 9,100 movies, over 18 million ratings from 62,000 users. In overall, we have 153,000 track. For each movie, on average, we have 16.8 track with standard deviation 8.3. We are interested to see how these features evolve over time. So for each year, we have the average of that feature, and you can see a positive trend at the beginning for danceability, but after 2000, we see a slight negative trend. Also for the energy, we see a similar pattern until 2000, we see a positive trend, but after 2000, we see that negative pattern for energy. For tempo, we are seeing a slight positive trend until 2000, and around 2000, we see a small negative trend. And as we can see in all these three features, we are watching a positive trend before 2000, but a negative trend after 2000. For valence, the measure that shows how positive the track is, we are seeing a similar pattern around 1980 or 1990. We see that before that, we have a positive pattern, so we have more positive songs, happy songs, but after that, we can see that we have a negative pattern. So we can conclude that After 2000, around 1990, up until that time, we had very happy, high tempo, high energetic, and we had that pattern in our movies, the soundtrack. But after that, we are seeing that the energy, the tempo, the valence is constantly having a negative pattern. So we don't expect to hear live recording in soundtrack, but as you can see here, we have that constant negative trend for the liveness. So instrumentalness tells whether there is a vocal content in the track or not. Higher values means that there is no vocal content. And as we can see around 1990 or 2000, uh, before that we have a negative trend. It means that we are getting more vocal content, but after that the amount of vocal content is getting lower. And in this chart we are seeing the evolution of acousticness. And as we can see, there is a negative trend before 2000, and after 2000, we are watching a positive trend. So in all these charts, there is a specific characteristic that there is a trend shift around 2000. So there might be one reason for that, because around 2000 there is an introduction of digital music composition. So this might have an influence on how music composer or composing music, and why this trend shift is happening around 2000. For doing the recommendation part, we are using the k-nearest neighbors content-based algorithm based on cosine similarity. So in this algorithm, we have a set of users and a catalog of items, and for each user, we have a provided preference score for each item. And also we have a similarity score between two items. This similarity score is based on a feature vector for each movie. And for each item or movie, we have a set of nearest neighbors that are closer than a specified threshold. This set is called NNI, and nearest neighbors. And we are computing the rating for unseen item for each user based on the formula written here. So at the first step, we are making sure that each user has at least 10 ratings equal or higher than 4. And then among these users, we randomly select 4,000 users because it is computationally expensive for us to do the full experiment. So for each selected user, we choose two items with rating equal or higher than 4. It is a favorite set of items, and we add 500 random items that are not rated by the user to this set. Now we have a set of 502 movies, and we use the algorithm and predict the score for each movie, and we order this set based on the predicted rating. In order to calculate the number of hits, we will compute how many number of favorite movies appear in top n movies. So it could be 0, 1, or 2. So we have 5 different systems. 4 of them use this automatically extractable features, and the other one use tags as a source of feature. So as we can see here, the system based on audio features uh, perform slightly better. Again, for the precision, the system based on the AudioLens features performs much better compared to the tags that are manual features. And again, we can see that the visual features and musical key-based features are performing equally. Here we have the result for the root mean squared error. We can see that the system based on the AudioLens features have the lowest error. So regarding the coverage, we are getting 100% coverage for the system based on AudioLens features and visual features. And the worst one is the system based on manual tags. So as the results are showing, the AudioLens features are performing better in the simple setup, But for the hybrid method, we are not really doing good in it because our hybridization method is not good enough for this data. So we need a more sophisticated hybridization method to do the task of recommendation better compared to the other system. So why are we using a simple setup and k-nearest neighbor algorithm? So the reason is that the algorithm is not the contribution of this paper. So we are just want to show that these features could be useful and just we did it in a simple way. So as a future works, we are seeing that the results in offline experiments are promising, and we are interested to see how these features performs in online evaluation. As another research topic, we can try to explain the outcomes of our recommendation to the user via these musical features. So explainability, one of the hot topic in the field, and we can just use these features to solve this issue. In another study, researchers found the correlation between musical features and facial expression. So we are interested to see the correlation between visual features and musical features via this facial expression. It is also possible to solve new user called start problem with this method. So instead of asking user about the previous movies that he has seen, we can just ask about the user's Spotify profile and then use the user's musical preference for movie recommendation. So it could be interesting to find application in video editing software. So instead of recommending video based on musical features, we can do it differently. We can recommend soundtrack for movies based on visual features or the desired feelings the user wants to convey. So this has lots of application for videos that people are posting in social media, such as TikTok or Instagram. So if you have any question about any part of this paper, you can just try to contact the authors with the provided links.